Hello, everybody, and welcome to this third session of Automation Saturday. So this is Stefano Tempesta. I'm dialing in, so to speak, from Australia. I'm based in Melbourne. And today we talk about blockchain, but I want to do in a very peculiar way, if I can say so. I want to do in the context of automation, in the context of the Power Platform, and not in the context of Bitcoin. Surprise, surprise. I know that most of you may associate blockchain with Bitcoin. You may have heard that there has been a halving of Bitcoin yesterday or the day before. So that means if you're mining Bitcoins, you're probably getting, you are actually getting half of what you used to get before. Is it the right time to invest in Bitcoin? This session is not about cryptocurrency, so I'm not here to give any financial advice on high-risk investment. I'm here to talk about these three guys: blockchain workbench, blockchain service, and blockchain development kit. These are three powerful applications that you can find in the Azure platform, which respectively will enable you to create blockchain workflows, and we'll go through this session and understand what these workflows are, what they meant, and why they're important. Deploy a blockchain infrastructure. So what is blockchain? Well, blockchain is a combination of computing, networking, storage. It is distributed, though. It is decentralized. So it still runs somewhere in the cloud, but it doesn't, there is no one that owns this infrastructure. It's really a peer-to-peer network. Still, we need some sort of virtual machines or containers, or a decentralized architecture. So blockchain service enable this. Is a service in Azure where you can deploy blockchain networks infrastructure in minutes. And then when blockchain runs, there is computing, as I said, there is storage. How do we connect external applications like a website, a CRM, ERP system, Dynamics CRM, Power Apps into a blockchain network? That's the power of the development kit. The development kit is embedded in Power Automate. It's one of the hundreds of connectors that are available, and you can just use it for integration of any external system with a blockchain network that you deploy on Azure. There are a few of these blockchain ledgers or frameworks that can be deployed. I will show you something briefly. You may be familiar with Ethereum, with the Hyperledger fabrics. You can do this and much more in Azure. But I want to take a little step back just to create the context, because I mentioned at the beginning, this is not about Bitcoin, it's not about cryptocurrency, it's about blockchain in the enterprise. So the enterprise, the business, they have some integration requirements, and you are all familiar with this. There is a CRM system, there is ERP, payroll, but even more traditional ones like file storage, FTP. Do you know how many customers of mine still work on FTP servers nowadays? A lot. SQL APIs and so on. We need to have a line of business applications to talk to each other. And how many of you guys have always have worked on these integrations? And I know that now Power Automate makes it easier. But before Power Automate, we were working on these custom interfaces and protect this interface, making secure, scalable, high available, big effort. So challenge number one. Challenge number two, we need to communicate over web, mobile apps, SMS, voice, and nowadays both IoT devices. Think of a supply chain that you can build in your Dynamics Cloud with F&O. There are multiple parties that are involved into delivering one stage to the next one. And I will show that actually as part of this session today. So all these different parties, they have to create a trust between moving one stage of the supply chain to the next one. They can rely on obviously human intervention, so signing some documents, some paper to go from one stage to another one. They can work with a level of communication that is slightly more automated, like a mobile app to just check in that, say, a carrier has completed the shipment of one piece, one parcel, and then is taking over to the next one. There can be bots that automate these things. I will talk today about connected supply chain with IoT devices. But still, there is something missing, that is the level of automation that and machine to machine that is not relying on human intervention and is in need of some level of trust that these traditional technologies cannot address. I'll try to make myself more clear in a moment. And the third point is that connected to this trust that we need to create between parties to automate processes, we need to have a way to verify transactions of any asset, sign them, verify them, and make sure that something exists and is authentic, so it's not been counterfeited. And this is where blockchain comes into place in creating this proof of existence, proof of authenticity, and even an independent audit trail. Let me guide you through this process so that we can appreciate. And this is not a blockchain 101 or 0 to 100 in 10 minutes, because I want to focus and I want to show you a lot of technology today. But just to give you a bit of context, we are all familiar with the traditional digital transactions. We buy a flight tickets. Probably not many people are buying flight tickets in the last couple of months, but in general, you're familiar with the process. We buy from an agency or directly from the airlines, and they store this information in a central database. They own the flight ticket, the ticket itself. They issue a number. So whenever we buy this asset, at the end, this information is stored in a central database. And we are all coming from an IT background. We know that central databases or central resources in general represent a single point of failure. Now, don't get me wrong. I'm not saying the airlines, it can be here a bank, it can be any other entities represent a failure, a weak point. It's the concept itself that represent a single point of failure being centralized, because if it goes down, it's simply not available. If there is a hack, a cyber attack, then that central database is compromised. Obviously, there is technology for high availability, redundancy, security and protection, but still remains a single point of failure. In the financial world, so now we are getting more into what you are familiar with blockchain, so in the terms of digital transactions. So from a financial perspective, say if Alice has to transfer something to Bob, let's make the example of any payment. You are familiar obviously with bank account or PayPal or credit cards. So there is an intermediate in the middle, Dave, that authorized this. If Alice is allowed to transfer $100 to Bob, is because she has $100 in her bank account or on her credit card account. And who is assessing or verifying this transaction? Is your credit card provider, is your bank account provider, is a ledger. A ledger is a sort of a database that contains all the transaction and input and output, debit and credit with a timestamp, who did what and when, and your final balance. You can again understand that this is a single point. Let's not use the word of failure, but it's a single point of authority that controls that Alice is in doing this transaction to Bob and authorize it. If that service is not available for any reason, Alice cannot complete the transaction. But then being in this position of control on transaction, you all know that your bank account, your credit card provider can apply some fees and make you pay for it. And in context of the world that we live today, the free world where we live today, there is competitions, so price fees are going down more and more. But in other contexts of monopoly, then it would become probably the only option possible, and not and not what the freedom of transaction would probably expect to have. But I'm going a bit off-road here, and this is a larger level of conversation. So let's go back to my point on identifying how blockchain can help and assist in making automation of a transaction possible without human intervention, creating trust between technology. So the centralized world, we understood, we rely on a central authority to authorize a transaction. So what is the decentralized system with a distributed ledger that blockchain introduced? Well, this is basically saying that we have a peer-to-peer network where everybody that is inside this network, so say all the clients of the bank, all the users that use that credit card, but now it's not one single bank, it's not one single credit card, it's a blockchain network. We sign into this network, and we listen carefully. We have a full copy of the digital ledger. So we have a full copy of all the transactions that everybody has ever done. Now, hold on. I see you, well, I don't see you, but I can feel the panic here. Say, you are telling me that everybody in this network get a copy of the database with all the millions of transactions that everybody has performed, and they can actually see this transaction? Well, yes and no. Yes, that's actually right. A digital ledger is distributed and everybody has a copy of it. No one owns it, everybody has a copy of it. But no, the transactions are encrypted, so you can actually see it. So now, let's go back to my point around trusted automation. What happens in a traditional transaction is what we have seen before. Alice wants to transfer some money to Bob. The authority in the middle, which is the central authority, authorizes the transaction or not. How can we authorize a transaction in a decentralized world where everybody has a copy of it? Well, we need to sign these transactions, put a timestamp on it, and put a signature, which in technical terms is a hash value. Now, if you are a bit familiar with cryptography, you may know that a hash is a unique number, typically 256 bits, but there are different lengths as well, that identify in a unique way a piece of content, a sequence of bytes, any digital asset, not necessarily cryptocurrency, not necessarily a PDF, any digital asset can be signed, hashed, and this signature is unique. And the great thing about hashes is that they cannot be reverse engineered. So by knowing the hash, you cannot go back to the digital asset. It's sort of one way only. Now, I didn't say that before, but a digital ledger is like a database with all the transactions, yes, but it's a sort of append-only database. So basically, you don't go and update an existing record. You can't even delete an existing record. You just go and append. Create new records in this long list. It's like an audit trail, with the benefit that this audit trail is distributed among everybody else. Look, you are familiar with a bank account, right? So if you make a transaction with your bank, you don't go and change the transaction because you did wrong. So if you say pay $100, they say, oh no, gosh, I didn't want to transfer $100. Let me amend that transaction and get only $50. Well, you don't do that. What you do another transaction to correct the previous one. So that's exactly what happens. And this is actually what happens with blockchain. So you keep appending new transactions. This creates an immutable ledger. And because it is distributed, so everybody has a copy of it, it's quite impossible to counterfeit, to tamper with it. Because if you want to modify the sequence of all these transactions, you have to go to all the dozens, hundreds, thousands, millions of people that are part of this network and modify every single copy. So if a hacker modify one copy of it and say, hey, Haley says $1,000, not 100, well, that's okay. We can kick you out of this circle because your copy of the digital ledger is different from anybody else. The majority wins. In blockchain terminology, this is actually called consensus. So we need to reach consensus. Now, consensus is an English word. It's actually a Latin word, but let's not get into that, which means all of them. Well, we don't need all of them to agree. We need the majority of people to agree that Alice has $100. So this is how a transaction in blockchain gets validated. We don't ask one single authority to validate, we ask the majority of people to validate that transaction. And because each transaction is a block of transaction, hence the name blockchain, is as a hash, as a unique value, if someone tampers with that information, the hash will be different. Because if you change a single byte, a single bit in a transaction, then the hash value will be different. Now, and what if someone say, okay, I'm part of this network, I'm a client of this distributed bank, but I don't want to be part of it any longer. So bye-bye, I go away. That's still okay. As long as we have a majority of people in the network that can validate the transaction, then the system keeps on working. So this, you guys are all with an IT background, I assume. You understand this is what a cluster, how a cluster works, providing high availability. We have redundancy, built-in redundancy in the network, because it's a peer-to-peer, everybody has a copy of this digital ledger. If someone is hacked, we kick him out of the circle of trust. If someone is offline, doesn't really matter. Everybody else will keep this network running. And this is how consensus, this is how validation is achieved in a decentralized network like blockchain. And now, built-in security and redundancy, as said, independent traceability. That's quite important. Every record is appended, so it creates a sequence, who did what and when, that is stored in this decentralized world. Now think for a moment to your CRM system, to your ERP system, to your enterprise content management system. Put a name on it. It is Dynamics, it is SAP, it is SharePoint. They all have a mechanism for recording an audit trail, who did what. No? So for example, you upload a document in SharePoint, you did a versioning of that document, and you know that Stefano has version document from version 1 to version 2 on this date, this document specifically. That is an audit trail. Now, tell me for a moment, where is this table that contains this piece of information stored? 3, 2, 1. That's right, it's stored inside the same database as SharePoint. So we have in SharePoint, in Dynamics, in Salesforce, in SAP, you name it, tables, or few tables, with the documents, with the users, with the different entities, and we have another table in the same database with the audit trail. Now, if an hacker tamper with the main database, the audit trail is inside there. So it can modify the audit trail as well. So it's completely pointless at the end from a security perspective. So it works from the sake of providing evidence until it is not compromised. Blockchain is somewhere else. Is a distributed network. I have a copy. You have a copy. John have a copy. Daniel have a copy. Raz have a copy. We all have a copy of it because we are all part of that network. So if my copy gets compromised, we can rely on everybody else's copy. So independent traceability, which helps to mitigate dispute on transaction, and very important, and now I reconnect, so I close the loop and go back to my trusted automation, provide proof of existence and proof of authenticity. A transaction exists because it is time-stamped, so I know when happened, and because it is in a digital ledger that is in append only, I can never delete or modify. So I know that if something is stamped, boom, did you hear the sound? Boom, that's the stamp. It means that it happened and it can never be modified. And it's also authentic. There is a signature, a hash value. If the hash value has not been tampered with, then it is authentic. I will show you how to verify this in a moment, okay? All right, so let's get to the level of technology that blockchain is required and is implemented in Azure, okay? So this was a little bit of conversation on creating the context of blockchain in the enterprise. But when blockchain started about 10, 11 years ago with Bitcoin, so or cryptocurrency, the first version of blockchain, so to speak, it was purely about crypto transactions, digital transaction of cryptocurrency, which is basically if you have enough Bitcoin, then you can do the transaction. If then, simple as that. That's not enough. So then, a few years later, Ethereum came out with smart contract. Smart contracts is your validation theory, your business logic that validates that a transaction can happen not just because you have enough cryptocurrency, but because there are some other conditions for a transaction to be validated. Now, smart contracts operate only inside the blockchain itself, so inside the data that is in this digital ledger. But the real world is not made of digital ledgers only. It's not made of blockchain only. We need much more than that. And to have much more than that, like a CRM, a website, an ERP system, we need to inject data safely inside blockchain. Because if we add rubbish to a blockchain, we're storing rubbish in the audit trail, right? So you get that. So a few years ago, Microsoft pioneered this space. It was exactly the first company to work into this space to create confidential computing among multiple parties, so among a CRM website, to inject information inside a blockchain in a secure way. So let's go and show you how that looks like. It looks like, this is an architecture reference, where you have data sources of different types, database, applications, sensor data from IoT systems, API, an ingestion hub. You have a database for storing traditional information, and you have a blockchain ledger. You see somewhere there in the middle, up in the middle, blockchain ledger. So as a reference architecture, blockchain is part of the solution. It's not the only solution. So I want to make clear here that when we say, okay, let's build a blockchain solution, there is no such a thing as a blockchain solution. Blockchain is a piece of component that is part of the solution. You don't build an Active Directory solution. You don't build a SQL Server solution, right? You build something where there is Active Directory, there is SQL Server into it, there is an Azure function, but you don't build a API or a Azure function or not even a Power Automate solution. It's part of the whole. So make sure that if you talk to customers, if you are a consultant, there is no such a thing as a blockchain solution that you can sell. Is part of the overall infrastructure, and you have probably recognize a few names here that are specific of the Azure cloud, and vice versa. If you are from the client side, don't believe consultants that are trying to sell you a blockchain solution. Blockchain is a piece of technology that is part of the whole. And let's try to understand a couple of use cases where blockchain technology can be used in Azure to solve some of the challenges that we have, especially in the automation space. Now, very briefly, actually, before, instead of showing this on a screenshot, which may be also be old, let me go into the portal. This is Azure portal. Okay, so if we go into the marketplace, so I want to create a new resource here, and going to the Azure Marketplace, you will see there is a blockchain category here, right? So we have machine learning, analytics, computing, containers, database, as you're probably familiar, and we have also blockchain. If you click on blockchain, let me expand this so you can see them all. You see that we can create a blockchain service, which is one of the guides that I mentioned at the beginning to create a highly available independent blockchain network. We have Ethereum, Hyperledger, Ripple, and a few other things. Okay, so this is how you create a blockchain network in just a few minutes in Azure. What are you actually creating? At the core, you're creating virtual machines running Linux. If you're running Ethereum, Hyperledger Fabric, blockchain service does a few more things. It creates also a SQL Server database for off-chain storage. It creates a service bus for communication. I'll get into some of these components in a moment, but just want to show you that how easy it is to create blockchain in Azure. It's like creating a virtual machine or a few of them to work all together as a network. Okay, but let's carry on. And I'll talk about blockchain Workbench later. One is a no-code application. No, most of you guys are obviously familiar with Power Apps, so it has a no-code or low-code environment for building apps. Blockchain Workbench is the Power Apps blockchain. Is the application that you can deploy here, where it is, here it is, blockchain Workbench, okay, to deploy this low-code, no-code environment for building blockchain smart contracts and running integration with any other system using Power Automate, because Workbench exposes an API and allows for integration with other systems. Workbench also has a SQL database attached for off-chain storage. What does it mean? Anything that is inside the digital ledger is on-chain, inside the blockchain. But Workbench provides also off-chain telemetry, typically, for measuring the usage, the consumption of the blockchain network itself, which can be used for some analytics on performance and usage in general. And also has a strong integration with Active Directory, because everybody that is part of the network has an identity. It is validated in some way. Okay. And let's move on with a specific case, and I will show you a quick demo of a supply chain built using Azure IoT Hub and a blockchain, obviously, a blockchain service. So the use case is this. We have a producer of some goods, let's say some milk, that has to be transferred to the store next to the corner. If you are in Australia, you're probably familiar with 7-Eleven. They are open from 7 in the morning to 11 in the evening, and they are every single corner of Melbourne. You will always find some 7-Eleven. So you always have a bottle of milk ready for you to buy. But how do they get this that milk in store? There is a long process, and this process is a supply chain process that starts from the farm, goes through some food processor, carrier, warehouse, another carrier, and so on. How do we get milk from the farm down to the retail store in a way that we, it is in good condition or quality? Well, each stage of the supply chain is validated, and we we make sure that there are good conditions for this milk to be transferred from one stage to another one. So let's assume that these conditions are temperature between 5 and 8 degrees and humidity between 56 and 60%. So these are conditions. These are set in a contract between the producer and the food processor. They may be different at each stage, and they have to be measured and validated. This is a perfect scenario for a synergy between IoT devices that measure temperature and humidity and a blockchain network that, using smart contract, can validate this, and if they are not valid, basically stops the supply chain with no human intervention, because a smart contract running in blockchain, which runs in the cloud, which runs on computers. IoT devices run as devices that connect to IoT hub, that runs in the cloud, that runs on machines. So this is machine-to-machine communication. If the smart contract, the condition in the smart contract is not met, the supply chain stops automatically. This is creating trust in automation without any human intervention. Okay, so we are now, this is all on GitHub, so open source, you can play with it. I'll share URL at the end. We have this supply chain with high IoT tracking of temperature and humidity. We have different roles that are involved into the supply chain. We have the device, we have some owner and observers, but what is more important are the different states, which is basically the supply chain or the transaction is created, is in transit, is completed, or is out of compliance. Excuse me. And this is where I want to focus. I want to focus on the out of compliance situations. I want to focus on identifying when a transaction that has been created and is in transit then violates some of the conditions that are defined in a smart contract. So to do so, I have some IoT devices. Obviously, because now we are in the virtual world, I cannot show you the IoT devices. When I do this sort of a session, I bring with me a real IoT device to measure the temperature. So I'm going to go into IoT Central and simulate a device. Obviously, IoT Central is a system that is hosted in Azure Cloud, where I can control real devices, IoT devices with a sensor for temperature, humidity, location, you name it. But in this case, obviously, because we are all virtual, I have to simulate the device. So I have created a simulated device that measures temperature and humidity. And I said, I can add here also real devices, but then I go and set some conditions. Okay, so let me open this device here, and I simulate the generation or the measurement of humidity and temperature. Now, with IoT Central, I can also set some boundaries, okay? So IoT Central will generate some random numbers of temperature and humidity, but I want to be a bit more specific, more realistic in some way. So I say, hey, please measure in Celsius degrees between 2 and 5, okay? With no decimal places, so whole number between 2 and 5. So I'm telling IoT Central to generate some random values of humidity and temperature. And as you can see, every minute there is a generation of a telemetry point. And then I set a rule. I set a rule and say, hey, if the temperature is greater than 6 degrees, send an alarm. Now, this alarm, because this violates the condition, okay? This alarm obviously can be just send an email, send an SMS, do whatever you want. But what I'm gonna do more interesting is run a flow, okay? And this flow will get in communication with a blockchain digital ledger. I will tell you exactly how that works, but for now, what is important to understand is that when a rule is fired, and the rule is fired is an action that is part of the blockchain development kit. So if you remember when we spoke about the blockchain development kit, so this is something that is in IoT Central. So we say, okay, hey, IoT Central, give me this rule specific temperature greater than 6 degrees. Then I build a request that is made of a few parameters. At the end, contains a JSON payload with humidity, temperature, timestamp, a unique request, and send this to a service bus that is associated to the blockchain digital ledger. Okay, I'll get into that in a few minutes, more into the details. This goes to blockchain. What you're seeing now is a blockchain workbench. Okay, in Workbench, I create a contract between the device and the owner of the transaction and the observer. So these are the two parties in the transaction. And I set the condition: humidity between 25 and 65, and temperature between 2 and 5. This is a smart contract. So in this moment, I'm adding or running actually this smart contract in blockchain. This means that this contract has to be valid between these two parties. And blockchain Workbench gives me this visual status update. Now I take an action and say, hey, transfer, so move to the next stage of the supply chain. And I choose symbolically shady shipping. This is my carrier, shady shipping. So you will see that now the transaction moves into the next stage, which is stage number 2, so status number 2. It is in transit and has been assigned to shady shipping. Now, the name shady shipping is not coincidental. This shady shipping carrier has a broken IoT thermometer, and they still want to sell my milk anyway. But I want to make sure that this doesn't happen. And I don't want anybody to go and check the temperature. So what I'm going to do now is edit the generation of temperature to simulate the broken thermometer, so or fridge, the broken fridge. So to generate temperature that is much higher than 6 degrees. So I say between 20 and 30 degrees. So now in a minute, IoT Central will simulate the broken fridge. So the sensor will measure temperature that is quite high. And we got the peak, and we got about 24 degrees here. Okay, so this temperature of 24 degrees is higher than 6, so it will trigger the rule that we set, and will run in blockchain the transaction to be out of compliance, because it violates the condition that I set in a smart contract completely automatically. So now in blockchain, I have a record appended to my audit trail that is out of compliance. Not only the status, but if I scroll down and see the details of the transaction, I also can see that it came from sensor type number 2, which is temperature, the sensor reading 26. So I know exactly what happens, but what I care the most, it is out of compliance. So I managed to achieve automation in a process, in an industrial process of supply chain without any human intervention. At this point, out of compliance, I can stop the supply chain. All right, so from a technical perspective, the way it works is that the IoT device is running in IoT Central. There is a rule. It goes into Power Automate. The screenshot that you have seen still refers to Flow, but this is obviously Power Automate. Power Automate sends a message to a service bus, and the service bus talks to Ethereum. This is how the confidential computing works in the Azure space. If you remember, blockchain 3.0, how can we inject trusted information inside a blockchain without introducing rubbish? Well, Power Automate send a message to the service bus, not directly to the blockchain. The service bus, that service bus is registered with a typical topic, so pub subscribe pattern, to transfer information to Ethereum. So only information that is sent to the service bus, so only from the application that are registered to that service bus, can send information to Ethereum and not anybody else. So Ethereum or any other blockchain in this case. Blockchain Workbench works with Ethereum, so this is why I'm mentioning Ethereum. So in this case, we are able to send quality information inside the blockchain, because once inside the blockchain, it will be stored forever. And the integration flow works on building a payload and creating a timestamp, a request ID, a user ID, send it to the service bus. In the interest of time, I'll skim on this because I have another use case that I want to show where I will go more into the detail of how this flow is built. Okay, and the second use case is a digital signature. So we have obtained a sort of automation in between parties, without human intervention. So the second part is the proof of existence and the proof of authenticity that something exists and has not been tampered. Is digital signature, but not the traditional digital signature that you know in PDF documents. With the guys that Adobe Sign, DocuSign, where you sign a document, the signature is stored inside the PDF. You send the PDF, who received the PDF opens, then connected to the central authority to verify the signature and validates the document. Now, this is a digital signature of any assets. And I have a quick demo that I want to show with you. So let me go off the slides back into the browser. This is a website that has a blockchain backend for hashing documents of actually any digital asset, not just document, storing somewhere. This backend uses SharePoint, but I don't care where the document is stored. If you can see here, it is very important to understand that the files are not stored in the blockchain. What it matters is that I store a unique cryptographic digital key, so the hash value of the document and not the document themselves. So I'm gonna connect here with my identity, because this is obviously I need to be authenticated, and upload a file, which I have it somewhere here. I have a file, a diploma. Okay, so pretend here that I have a diploma that I have that I'm uploading into this document. This diploma is being generated by my university. Do you want to know what is inside? Okay, fair enough. Let's go and have a look. This is my diploma. It's been issued by the Marvel University to certify that Stefano Tempesta is a Power Ranger. Okay, so I'm officially a Power Ranger, and Marvel University has issued this diploma, and I'm proudly hanging this on my wall. And I'm applying for a job or I'm immigrating to a country, and I have to prove that I'm a Power Ranger as a requirement for this job or for immigration. So I send them this PDF. So now what happens is that I'm now signing this. So this is uploading now on this website. The PDF is being stored somewhere. There is a storage backend. In this case of this application is SharePoint, but as I said, it can be anything. But what is important is that I'm capturing a signature of this document, and the signature is this combination of numbers here, and the document has been successfully registered in a blockchain network. All the parties that are inside this blockchain, so the institute that issued the Marvel University, myself as a student, the Department of Immigration, or my employer, are nodes, so users or parties of this network. They all receive this transaction, this copy. Now, fast forward this to 5 years from now, 10 years from now, 20 years from now, and I have another requirement for another job, another immigration, another need for validating my diploma. But surprise, surprise, the requirement is not for a Power Ranger anymore. They want a superhero. They want Batman. They don't want Power Ranger any longer. But oh gosh, but I really want the job. You know what? Let me bluff. Okay? So I'll go and Photoshop it. Now, instead of doing a Power Ranger, I'm a superhero. Okay? I save this, save it as a copy as PDF. Save here. The document already exists. Overwrite. Okay, so I close here. Marvel diploma. Now I'm a superhero. Hey, hey, I photoshopped my degree. Who cares? So then I go here and verify. And so now I'm sending 5 years from now, in 20 years from now, I'm sending my diploma again to another employer, Department of Immigration, whatever that is, and obviously the validation will fail. Okay, this is not a special effect, and we don't need blockchain for this, right? So this is simply comparing one document to another one. The documents are different because some bytes have changed, and obviously the validation fails. So there is no magic here. But where is the value of blockchain in this? Well, the value in blockchain is that, let me go through the process. When the institute issue the document and sign it, and they store it somewhere, they sign this document and store it in a blockchain, which is, if you remember, is immutable. It never changes. So I get an authenticity token, which is the address of the smart contract where this validation is done, which is unique to me. It will never, never change. One day, I'll skip this, I'll come back later. I'll go and validate this again. So I will send my PDF, which I have modified. I'm no longer a Power Ranger, I'm a superhero. So what the authority verifying the document do is they will hash the document, get the signature, and compare with the value that was stored 5 years ago, 20 years ago on a blockchain. If they match, the document exists and is valid, it's not been tampered. If they don't match, hey, someone tampered with my document and is not valid any longer. Okay? It's not the same document that was issued 5 years ago and it was stored, the hash value, 5 years ago with that exact value. So how do we achieve this in the cloud, in Azure? Well, instead, again, let me go in here and show you this logic app that basically does this integration here. Going to the designer and basically says, open, come on. There we go. When a file is created in a folder, and you see this is SharePoint, I can put anywhere. It can be OneDrive, it can be any repository, it doesn't really matter. Hash the file content. This call a function to do the hash. Hash the metadata, and now this is specific to SharePoint, so I'm hashing content type, file ID, file path, but you can hash any metadata that is helpful to identify the document. Then create a request ID, a GUID. Anything unique is a request ID. Create process date time now, okay? And then the user chain identifier, which is my ID in a blockchain network. So every user in the blockchain has an ID. The registry, so the function that I'm invoking, but what is more important is the message. This message is, again, a JSON payload with all the information that we need to build. And this message is a send message to the service bus. Okay, so we get the same pattern that we have seen also for the IoT supply chain. The way that we communicate with a blockchain network is sending a message, JSON message, to a service bus. The service bus is in publish subscribe with Ethereum Digital Ledger and is the only way to enter information inside the blockchain. Okay, so all the source code will be shared, so you will have plenty of time to go through that. And I have also written an article that will guide you step by step in building this application. So feel free to reach out to me if you want to explore more of this information in detail. Now, in the interest of time, I have to run a little bit, so to leave some time for some questions at the end. So just to complete this conversation, first of all, the benefit of signing a document of assets in a blockchain is that it can really sign anything. It doesn't have to be a PDF. It can be any digital asset. The signature is stored in a blockchain, the document anywhere else. I don't have to transfer the document or the asset and the signature together, which has two advantages. One is there is no central authority that verifies that document. If you sign your document now with, again, let me say the names, DocuSign, Adobe Sign, and in 20 years from now, these guys don't exist any longer, your signed document has no value because it cannot be verified. Right? Instead, if the signature is stored independently in a peer-to-peer network that is expected to exist over time, then it doesn't matter where the document is stored as long as the signature exists. And because I'm not transferring the signature with the asset itself, then multiple parties can verify the same asset at the same time. All right, if you want to get started, Microsoft.com/blockchain is your starting point for all the marketing proposition around blockchain. More specifically, that architecture, the solution around the IoT connected supply chain. There is an architecture reference at the URL that you see on screen. So there is a very nice detail how to implement this in Azure. Get in touch with me directly if through LinkedIn, Twitter, whatever you prefer, for more details on the implementation of the digital signature. All the source code is on GitHub, so happy to share it. And at the end is blockchain as a service, blockchain workbench, and any components of Power Platform, IoT Hub, Service Bus, as mentioned, to work all together. All right, we have a few minutes for a few questions. Go ahead and ask. Hey, Daniel, how does it work? Do people ask in voice or in the chat?
They can do both.
Okay, cool.
So I don't see any yet. There's Antti.
What is the cost of Azure Blockchain Service? Great question. So blockchain is actually open source, free of charge. So you pay nothing for blockchain service. What you pay for is the infrastructure that you deploy. So what is blockchain is some virtual machines with the Linux, is some networking, some storage. So it's like you deploy a virtual machine in Azure. When you deploy blockchain service, you decide the size of the virtual machine. So you pay for the virtual machine that you're deploying. But there is no license cost. It's all open source. So in theory, you can deploy a normal Linux virtual machine and install Ethereum by yourself. Good luck with that.